Hello everyone, welcome to my YouTube channel. Today in this video I am going to explain you about the basic of fluorescence microscopy. I will be explaining you about the simple model of microscope, that is fluorescence microscope of course, and the ray diagram are simply the passage of light that undergoes or that actually happens inside the microscope. As we all know, microscope is an optical instrument which is used to magnify tiny objects so that a larger and magnified view of that object is visible, and it helps us to study the properties of that object or specimen. Now, what is how is fluorescence microscope? How is fluorescence microscope different from normal optical microscope? That might be the question. There is a difference in that there occurs fluorescence. So what is fluorescence? Fluorescence is the property by virtue of which a fluorescent substance, when a light is incident on it, it absorbs that light, it gets excited to higher energy level, but it cannot remain in high energy level for longer period of time. That's why it has to come back to the lower energy level. While doing so, it emits light but of longer wavelength and lesser energy than incident light. So that is what fluorescence is. So fluorescence is the emitting of longer wavelengths of light, longer wavelength light when a light of certain wavelength is passed to it. Alright, so that is what fluorescence is. Now when we combine fluorescence inside the microscope, or when we put this principle of fluorescence and design a microscope, then we obtain so-called fluorescence microscope, right? So the thing you are seeing right here, it is the thing you are seeing right here on the screen, it is of course a diagram or design of fluorescence microscope. Now I'm going to explain what happens. So this is light source, here we have specimen. This specimen is not only specimen, but this specimen is coated with fluorescent substance, and this I have used a clip art to look at see like human eye. So this is just human eye, right? And there is lens, this is eyepiece of course, and the lens toward the object, it is objective. Now let me start to explain how an image is formed. All right, now let's begin. As I had just previously said, this is a source of light. I've shown it like a bulb, but it is not actually that tungsten bulb. It is a different kind of light source. I have just kept this bulb to represent the light source. Don't get confused with the normal tungsten bulb. So this is a light source, maybe mercury arc lamp, right? So this is a light source, maybe mercury arc lamp. From this light source, we obtain a white ray of light. White ray of light is obtained from the source, from the light source. Then we just need a single wavelength of light. As we all know, white light comprises of or contains several wavelengths of light. That's why we use a exciter filter. We use exciter filter so that only a single wavelength of light is allowed to pass through it. That is, white ray of light is passed and only blue light in this case emerges out from the exciter filter. Now our purpose is to strike this blue light to this specimen, right? So what we do is, if this goes on this way, this is definitely not going to meet the specimen. That's why now we design a mirror, a reflector, so that the blue light is reflected, onto the specimen coated with fluorescent substance. So there is a dichroic mirror. This mirror is not ordinary mirror. This mirror is not an ordinary mirror because this is dichroic mirror. Of course, dichroic mirror has a special property that it allows only a certain wavelength of light to reflect at its surface and transmits all other remaining wavelengths of light. In this case, we have designed this dichroic mirror in such a way that it allows only blue color of light to reflect at its surface, whereas whatever other lights be green, yellow, orange, red, violet, all other lights, they are transmitted through this. That's why here blue light is incident. What happens now is that blue light gets reflected at its surface and strikes directly onto the specimen. As we just said before, specimen is coated with fluorescent substance. Since specimen is coated with fluorescent substance, now fluorescence occurs. That is, a blue ray of light is passed to a fluorescent substance, which I have coated it on a specimen. So we have passed blue ray of light onto a fluorescent substance. Now fluorescence occurs, and that's why the light emitted back from the fluorescent substance, or the light emitted back, it is not gonna be of blue color, definitely, because we need a light of longer wavelength or lesser energy. That's why the light that we obtain now is not blue, but the wavelength or the color of light that has longer wavelength than blue, which is, as we all know, if we follow the series of visual spectrum that we remembered when we were kid as Bibgyor, Bibgyor, and after B it comes G. That is, after blue it comes G. That's why green light has longer wavelength than blue color. That's why the light that is reflected back from the specimen is likely to be of, or in fact it is of green color. That's why green color light is reflected back from the specimen, and now it again strikes the dichroic mirror. Green light again strikes the dichroic mirror. As I just said a few moments before, I said that dichroic mirror in this case we have designed in such a way that it reflects blue wavelength of light and transmits all other. Now this time it's green. However, it is not completely green at this moment of time because some residual blue color still may appear here. That's why. Now what I was saying is that when this let's say this green, though it is not completely green, let's say this green. Now this light, when this reflected light when passes through the dichroic mirror, only green color can pass through it, or only green color is transmitted, because blue color would definitely be reflected because it is designed in this way, right? Green color, since it has longer wavelength, it is gonna pass through the dichroic mirror. That's why it has become a bit more green now, right? Now, though it is not still total green, we need a pure green spectrum of light. That's why we use another filter at this end, I mean at the end near to eyepiece. The filter name is barrier filter. As the name suggests, it is gonna filter some residual blue light. If it is still there, then it filters the remaining blue light, so that when the final ray is obtained, it would be of entirely green color. This green color light is visible. It is not just the light that we are dealing with. This light is the reflection of the specimen, because we had coated the specimen with the fluorescent substance. That's why the light doesn't mean that only they are seeing green and green, but the green would be the specimen itself, right? So the magnified specimen would be seen, the magnified object would be seen, so that the object would be seen dark green in color in the entirely dark background, because only the fluorescent substance are gonna appear, right? That's why we can obtain a green object in dark background, and that's our job done. Because I think I have explained you about the fluorescent microscope, its basic design. I hope you are clear with what I have explained. If you don't know, or if you feel difficult in understanding what I have been saying till now, you please let me know in the comment section. And if you think the video was worth sharing and liking, please do so. And please subscribe to my channel, so that you don't miss out my latest videos. And the comments that I had got in my earlier video, my first video, was my accent was too poor, and I think I have managed so far to correct it, and I don't think I've succeeded completely. What do you feel about my accent in this video? Please let me know once again. So finally, goodbye, and many thanks for watching this video. Bye bye.